Hi, Mr. Wright here, and welcome to this set of IGCSE exam questions, which are about grades 6 to 8. So these sets of questions are perfect if you're approaching your exams and you want to practice questions on a range of topics, all at a certain level. So hit the link in the description, download the questions, have a go, and then watch my worked solutions. If you find this film useful, please hit like, and if you have any questions, of course, leave them in the comments and I'll respond. Good luck.
Question 1. The diagram shows a triangle. Yes, it does. 3 side lengths as marked and an angle. Work out the value of x. Now, I've got a triangle. I know 3 sides and an angle, so I can use the cosine rule to set up my equation, I should think. Now, if I can use the cosine rule, I've got, this is going to be capital A, the angle I know, so that's going to be side little a. So cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So a squared, which is 2 root 7 squared, equals b squared. Doesn't matter which one I use, 2x minus 1 squared plus c squared, 2x plus 1 squared minus 2, lots of 2x minus 1, 2x plus 1 cos 60. Right. So I'm just going to be careful, I think. 2 lots of root 7 squared is 4 7, so that's 28 equals, multiplying out this bracket, that's going to be 4x squared minus 4x plus 1 plus 4x plus 4x squared plus 4x plus 1. Now I'm going to have a minus sign here, so I'm going to put this lot in a square bracket so I don't mess up my signs. Cos 60 is a half, so 2 times a half is 1, so I've only got to multiply out these 2 brackets now. That's going to give me the difference of 2 squares, isn't it? 4x squared minus 1. Close bracket. Right. 28 equals 4x squared's there, and another 4x squared gives me 8x squared minus 4x squared gives me 4x squared. X's, minus 4x plus 4x, no x's. Plus 1, plus another one is plus 2, plus another one is plus 3. So 4x squared plus 3. Now I've got to solve this to find x. So 4x squared will equal 25. So x squared will equal 25 over 4. So x will equal the square root of 25 over 4, 5 over 2. And that is question 1 done. Question 2. PQRS, that's the large quadrilateral, and PLMN, that's the small quadrilateral here, are similar quadrilaterals. Okay, PNS, PLRS. LM is parallel to QR. Okay, fine. All right, work out the length of MN. Let's just call that X for a moment. Right, now we know that the large quadrilateral is similar to the smaller quadrilateral. Now the large quadrilateral has a base PS of 20, and the smaller quadrilateral has a base PN of 12. So if I work out that scale factor there, 20 divided by 12, tells me that the scale factor from small to larger is 5 over 3. Great. Now I'm being asked to work out the length of x, which corresponds to the length of SR. So x is going to be SR divided by 5 over 3, because I'm going from larger to smaller. So 13.5 divided by 5 over 3 gives me 8.1. Good, so I can now label this one 8.1. Work out the length of LQ. LQ is this length here, isn't it? Now, here's LQ. If I knew the length of PQ, I'd be laughing because I could just subtract away this 9. And I can work out PQ because it corresponds to this 9, doesn't it? It's going to be 5 over 3 times 9, which is 15. So PQ is 15, which means that LQ is 15 minus PL, which is 9, gives me a length of 6 there. Okay, now the area of PLMN, that's the smaller one, is A, and the area of the larger one is KA. Well, I know what K is, because the linear scale factor is 5/3. So the area scale factor is 5/3 squared, or 25/9. So I know that the area, that K is 25/9. Great. The area of the shaded region is equal to whatever it is, 105.6. Find out the value of A. Okay, well, the area of the shaded region is the difference between the larger area and the smaller area. The larger area is KA, so the larger area is 25/9 times A minus the smaller area, which is A. That's the difference between the larger and the smaller, and I know that equals 105.6. So there's an equation. Multiply everything by 9. Well, actually, I'll just do 25/9 of A minus 9/9 of A. So I get 16/9 of A is 105.6, which tells me that A is 105.6 multiplied by 9 divided by 16, which gives me an answer of 39.6 square centimetres for the area of this smaller quadrilateral. And there's my solution to that question. Question 3. A solid cone has a height of 15 centimetres. Yes, it does. And the volume of the cone is 320 pi. It might be useful to remember the formula for the volume of a cone, which is that the volume of a cone is 1/3 pi r squared h. Okay. Work out the curved surface area of the cone. Well, the formula for the curved surface area of the cone is that the curved surface area equals pi r times the sloped height there. Okay. By the way, we've got to give our answers to 3 significant figures. Okay. So I'd like to be able to work out pi times r times L. Now I know r, but I don't know L. This is L here, this curved height there. Oh, I don't know R either, actually, while I'm at it, but I know the height. Okay, let's have a look at this first piece of information we've been given. We've been told the volume, which is given by this formula, is 320 pi. Now I know the height. I'm going to divide both sides by pi, first of all, and I'm going to substitute in the height, which is 15. Now I've got an equation which simply has r in it. So I can now divide both sides by 5, the r squared is 64. So the radius is 8. Brilliant. Okay, so now I know the radius is 8. So let's write that in here. Now let's go back to the formula for the curved surface area. Here it is. I need to find the curved surface area. I know pi, I know r, but I still need the sloped height there, L. I can use Pythagoras to find that. There's a right-angled triangle just here, height of 15, 8, and a hypotenuse of L. So L is going to be the square root of 15 squared plus 8 squared, which gives me a sloped height of 17. Now I can use my formula. Curved surface area is pi times 8 times 17. So 8 times 17 times pi gives me a solution of 427 square centimetres to 3 significant figures. There is my solution for question 3. Question 4. I've got 2 functions here. I've got function f and the function g. Express the composite function gf in the form GF colon X to something. Give your answer as simply as possible. All right, so I need to express GF of X in algebraic form. So I'm going to start off with f of x. Well, I know what f of x is. F of x is 2x squared plus 1. So now I'm going to g that. I'm going to g f of x. So the input is 2x squared plus 1. So that means that I'm going to have twice the input over the input minus 1. Now I simply have to simplify this fraction. So well, actually, I'm going to leave that as that for the time being. On the bottom, on the denominator, I've just got 2x squared. I'm going to divide top and bottom by 2. Gives me 2x squared plus 1 over x squared. And I should think that that is probably the answer. Or having said that, we could simplify that a bit more if we wanted to, perhaps, and call it 2 plus 1 over x squared. Okay. Express the function, the inverse function, g to the power minus 1 in the form g to the power, right, so we've got to find the inverse function. So let's just write down here so we can see it, the function that we're starting with. Here it is. Okay, now we need to find the inverse function. So I'm going to write y equals 2x over x minus 1. I'm going to rearrange this to make y the subject. It's going to multiply both sides by x minus 1. It's going to give me yx minus y equals 2x. I've got to make x the subject, so I'm going to put everything with an x on one side, minus 2x from both sides, and everything without an x on the other side, plus y to both sides. So obviously don't need that plus. Factorize the left-hand side. X lots of y minus 2 equals y. Divide both sides by y minus 2. So my inverse function, g minus 1, is x. We'll go to x over x minus 2. There we go. There's my solution for question 4. Question 5. The diagram shows the elements in sets A, B, and the universal set. Write down the elements in not A. It's going to be all of them except those elements which are in A. So the elements which are not in A are 5 and 6, 7 and 4. Right, find the complement of A intersection B. Well, A intersection B is the 8 and 9. So those that are not in A intersection B are all the others, 2, 3, 10, 5, 6, 7, 1, and 4. It asks me to find the number of elements in the complement to the intersection. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements which are not in A intersection B. Right, find the elements in A intersection B or something else. Well, the ones in A intersection B, is 8 and 9. So those two are going to qualify. They've got to be 8 or 9 or not in A or B, not in the union. Well, the ones which are not in the union are 7, 1, and 4. So to qualify, you have to be in either the first category or the second category. So there are 5 elements which qualify, and they are those ones. Okay, now let's have a look at this next one. Right. A intersection C is an empty set. So A and C have got nothing in common. All right. So C does not include any of the elements in A. B union C, they're in B union C. So either in B or C. Well, B or C is going to be those in B, 8, 9, 5, 6, 8, 9, 5, 6, it was 7. So 7 must be in C, mustn't it? So 7 is definitely in C, but I've got to have 3 of them in C. but none of them are in common with A. So it's going to be 7, 5, and 6. So the elements in C are 7, 5, and 6. And there is my solution to question 5.